So yes, I'm Chris Hales. I'm an Azure MVP. I'm also a cloud technology strategist for a company here in Sydney. I'm based out of Sydney, Australia, and I'm definitely enjoying some beautiful weather today. Today, we're going to talk a little bit through what's happened with VM Internet Direct. People might remember kind of some announcements that happened late last year, and then it kind of shifted and changed and delayed. But we're going to go through that again, and then we're going to start to talk about what our options are for what is the next iteration of how to obtain internet for virtual machines. I also want to note this doesn't impact platform as a service offerings. So things like the SQL databases, Azure ML, things like that, they're not necessarily impacted by this. It's more about virtual machines or resources that are deployed to a virtual network. They need an internet option now. So without further ado, what happened? What happened? Where did it come from this? And I've just realized some of my graphics are broken, but that's all right. We'll push through. So in kind of March this year, it was originally slated for September 2025, but in March this year, Microsoft changed the way that virtual network subnets allow for direct outbound internet. Now, that was effectively a change to the underlying API. One of the things that happens there was they've more or less just stopped it from happening. So when you create a new subnet now on a new virtual network now, it's not open by default. It's technically a private subnet, right, from now on. You can still change it, obviously, but the default is private subnetting. So this implicit source NAT, right, was available to everybody, which made deploying virtual machines super simple, right? You could deploy a virtual machine, you could put a public IP address on it, you could get your outbound, inbound RDP, or if you didn't put a public IP address on it, you still had internet access, so it could still reach everything on the internet. So that implicit trust of NAT versus what Microsoft wants us to do is to take more of a defensive measure and more of an explicit trust. So rather than being implied, we need to make a decision about how it gets to the internet, which is really important. Uh-oh, slide's not moving. Oh, okay. Yes, I've got some broken slides here. Let me just see if I can change this slightly, because this is going to make it a bit more challenging.
It's interesting while you go through that, because I think a lot of people, like, this change has been coming for a while and they've even pushed it out. But I think it's interesting because for those of us who've been using Azure for quite a while, it's almost like, hey, what's going on? And then a lot of things like Azure Virtual Desktop as an example, it's like, well, this is existing VNets will work, but when you start to scale them out, then you start to run into kind of inconsistent and like behavior. Yeah. So yeah.
Is everyone able to see my screen now? Better now?
Yep.
Working. Yep. Fantastic. I guess, and that's one of those scenarios, right? It had a blowout effect, right? Which is not necessarily immediate. It's going to be long term. But I think the other thing is that we're so used to it just being implicit that we need to change the way we think about that so that we don't fall into the trap. And we need to also modernize those older virtual networks and subnets that we've deployed, which is important as well. So yes, before, like I said, that implied magic SNAT, you deployed a virtual machine, hey, it's got internet, fantastic, right? But now we need to deploy a virtual machine you're not going to have on a brand new VNet, a brand new subnet, you're not going to have internet. So unless you explicitly configure it. And there's definitely, like I said, plenty of options. And we're going to wrap through a couple of them today. So that explicit configuration. So again, this is not Microsoft trying to be difficult. It's them pushing us all to a better security posture, right? We want to make sure that we make an explicit choice to allow internet from a destination or from a source, right? Whether it's if you've got a 3-tier architecture, for example, and you've got databases that don't need internet access and data tiers or application tiers that don't need it as well, why give it internet? So it's about making sure that we have an explicit decision to why they need it. And then how do we provide that in a secured way, or at least a controlled way? So some options I'm going to cover off in some detail. I'm going to not go too deep on some of this because For those that know me, I could probably talk about this stuff for a good couple of hours on each one of those solutions, because they've got some really good valid points. They've got some really awkward points. So the high level summary here is NAT Gateway is a super simplistic approach. It's quite a low cost and it's quite a low complexity. So it's that concept of the same kind of magic SNAT that occurred originally. Essentially, rather than Microsoft deploying it for you in the background and in the black box that is the Azure platform, you're actually deploying it as a resource and you're controlling it, right? So there's a concept around that. It also allows you to have a guaranteed single IP address, egress IP address, which is also important for some security aspects. Obviously, there's an Azure firewall. You can do that. It's probably a little bit more costly. It's got a little bit more complexity because it's got a lot more features, and it's more designed for that kind of security first organization that want to have inspection and they want to have visibility of their traffic and so on. So that's one of those challenges that we kind of face there. Anything that's currently behind a load balancer, so if you've got a web tier that's got maybe 2 servers behind it that you're doing some high availability between, you can also leverage that same load balancer, those public load balancers, as an outbound as well. So you could leverage that if you're only giving internet access to those external facing tiers. The network virtual appliance is a sticking point with a lot of different customers. The best way to, or easiest way to explain this is if you've got an on-prem environment currently, and say you've got a firewall vendor like Palo Alto or Checkpoint or Cisco, then you have an ability to potentially deploy that solution or a very similar solution of the same thing in the cloud. So you could use a network virtual appliance, which is essentially just 2 virtual machines or multiple virtual machines for high availability. But it creates a lot of cost because you're now managing a whole lot of load balancers on either side of it. You're managing the 2 virtual machines, you're making sure that they've got availability and high availability. And it also kind of extends your capability to maybe do a bit more multi-cloud kind of stuff. The other one, which is a little bit of a varied cost because there's kind of 2 ways of approaching it, which is those express routes and site-to-site VPN connections. So people that have got hybrid connectivity already with their Azure environment, you could choose to just go, well, I'm maintaining a firewall over here on-prem. It still functions, it still works. Why don't I just send my internet traffic out through that? You can do that as well. So using your on-prem for your internet breakout and stopping that any kind of internet breakout. So again, more of that security conscious kind of company that's got the heavy investment potentially in their on-prem security solution and want to see that inspection and see that granularity of traffic there. So option 1, the easy button is what we call it, because it's literally single resource or a couple of small resources, the NAT gateway and a public IP address, and away you go. And then you simply associate that with subnets. And there you go. You've got outbound internet just like what you had before with that whole source NAT approach. So it's a simple approach. It also allows for auto scaling up to the kind of 50 gigabit per second. So it's quite a strong kind of opening. It's got the scalability that you're looking for. It's one of those things that you've still got that capacity to kind of to at least determine which subnets should have internet access, which ones shouldn't. And it's quite simple to kind of maintain and manage. Again, it's a PaaS component, so a lot of that responsibility falls to Microsoft, but you still need to kind of manage and understand and maintain your own kind of configuration inside it as well. So one of the downfalls of it, obviously, is that there's no filtering, there's no inspection, there's no rules, right? So you can't say this machine can go to these sites. There's no level of inspection or content filtering or any level of control when it comes to that part. So again, need to consider what your organization requirements are versus what you can achieve. Option 2, Azure Firewall, probably one of my favorites, mainly because I'm a networking nerd and security nerd, but a really good solid solution, right? It's Azure Firewall, and there's 3 tiers of Azure Firewall. There's basic, standard, and premium. So you can get away with something super basic. Like, so when I mean by super basic, it does maybe the layer 2, layer 4 kind of, sorry, layer 3, layer 4 kind of options, right? So this source address to these sites or this external address, that's achievable. Or it can go outbound onto this port number, right? Or to this port number externally, and so on and so forth. So it's a very simplistic form of a firewall, but it's still a firewall, right? So you still get that slight level of inspection and that capacity to do at least basic rules around IP to IP or port to port. Obviously, the standard builds on that again with just some additional functions around inspection, and then premium are then further advances on that again, where you've got things like the TLS inspection, the IDS, URL filtering, and web categories. So you've got that real rich kind of layer 7 firewall capacity at that point. And the standard's like that step in between. It's still got all the inspection, probably got a little bit more broader kind of capacity around things, but doesn't necessarily have all the bells and whistles of something like TLS inspection. So FQM filtering and so on. So centralized logging, also really important, and it's fully managed, right? So it's a fully managed PaaS component. So the only thing you're managing is essentially your rule base, right? The unfortunate side of that is it's quite a bit more expensive, right? So the figure I've given you there is just based on current pricing inside Australia East for $520 a month, roughly, on the basic, with about a terabyte of egress data. So remember, you're not charged for data that comes into Azure. You're charged for your virtual machines making traffic outbound, so egress data, not ingress. And it does kind of require a bit more of a hub-spoke architecture. So if you're not someone that's got a hub-spoke architecture, or you've got a bit more of a dispersed architecture, you need to you do need to consider how you get your traffic through inbound and ingress through that firewall. So typically with virtual machines, you would use something like a user-defined routing table to point your traffic to the firewall. So it's a little bit more complex in that scenario, but it's a lot more of a favored. So it kind of this and the NVAs are kind of like the two kind of mainstream kind of approaches to this for the security conscious kind of organization. Virtual network appliance, like I said, that's the more complex one. It's definitely more. It's the same thing. You can do almost the same thing, if not more, than what you would have had from Azure Firewall. You can have it like you're doing all your SD-WAN if you're using Fortinet, for example, or Checkpoint and Palo Alto also have NVA products that are off the marketplace that can achieve the same thing. Same thing with Azure Firewall. However, you're now in control of all of it. So it's not the PaaS offering that manages all the underlying infrastructure. You now have to manage the NVAs themselves, so the virtual machines that are themselves, the load balancers, the public IP. So you're managing a lot more of the ins and outs and the technical components that make up the solution. And it also still relies on that hub and spoke architecture. So you still need to be using UDRs, for example, to move your traffic to it. So again, and there's probably a slightly more costly, right? Because it's not platform, it's not scaled to a platform level. So you've probably, you've got two virtual machines and you've got extra load balancers. So it's probably a slightly more higher cost, once again, higher than probably something like the Azure Firewall. And then the site-to-site VPN express route piece, again, it's if you've already got the hybrid connectivity set up and you've already got the security investment on-prem, this could be a really good option for you. It allows you to leverage your current connectivity, whether it be site-to-site VPN or the express route, and move all of your internet traffic back down through it. So you can move by, again, leveraging UDRs and also with site-to-site VPNs, or if you're using express route, you can utilize your BGP routing in order to, I guess, effectively advertise that the internet is accessible through your express route. And site-to-site have a concept called default site. So you can set your default local network gateway as the default site, and then it simply says, okay, I'm going to allow internet traffic to flow down through that site-to-site VPN. So a little bit more latency with that hairpinning approach, but it's, again, kind of want to maintain control on-prem, want to maintain the level of inspection and visibility that I might already have through my firewall, and then just treating the cloud or Azure as essentially a different spoke to my on-prem environment. Also, a big thing there would be to consider the bandwidth requirements, because if you're leveraging ExpressRoute for all of your business activity, you've also got to be now accounting for your business activity plus your internet, right? So you've got to think about your bandwidth sizing there. So the decision framework, the very simplistic traffic inspection, you need to think about things like firewall or NVAs. Otherwise it's like the NAT gateway, which will get some, but nothing to the level of detail that probably most security professionals would like. Existing load balancer, if you've got one already and it's already leveraging that, could you consider using outbound rules for that instead, right? And leverage it out the same way. That hybrid environment, that's where, again, that express route site-to-site VPN could be a good option for you there. And if you're looking at more of a budget constraint and budget consideration, the minimal viable product is probably that NAT gateway, right? And then if it's more of that security first kind of concept, you want to look to the firewall. So some implementation tips: audit your existing virtual machines, audit your existing virtual networks, and test this kind of functionality inside a non-prod environment. I think that goes without saying of pretty much everything we all do. Monitor the source NATs. So this is more typical specifically to the load balancing scenario. We have what we call port allocation exhaustion, which occurs inside load balancers, where we have, say, we've got only 2 or 3 inbound ports that are allowing through our public load balancer, but we've got 5 servers underneath it. And those 5 servers go bang and they go to the internet, right? So they've got ports for DNS, they've got ports for web traffic, they've got ports for system traffic, they've got port for update manager. So all of a sudden they start to exhaust the outbound port request, that SNAT port exhaustion. So there is an Azure monitor workbook just to monitor that part, and there's actually a metric for it that you can monitor it to make sure that you're not exceeding those limits. And document your architecture. Some of the times considering private endpoint, if you're in that hybrid connectivity model, maybe considering some more private endpoint deployment could be a way to reduce your outbound requirement, right? So rather than it going out via the internet to get to something that it could have potentially gotten through a hybrid connectivity model through using a private endpoint. So maybe think about where you leverage your private endpoint a little bit more. And that's it. That's all I've got. I think I'm almost bang on time. But a little bit early.
Yeah,
but I'm opening up for some questions.
I do have
any feedback for me today. Actually, I'd like to. If you've got any feedback from today's session, please use the QR code and submit some feedback.
QR code over here as he points this way.
Yeah.
I do have a stupid question that just occurred to me. The new network virtual appliance capability, versus route server. So
it's been a sticky one. Jose actually put out a really good article about the NVA. For those that don't know who Jose is, he's a product manager for the networking space in Azure out of Redmond. And he's done a really good piece around where does the Azure NVA fit versus the route server. They cover a really similar kind of requirement and concept. Ultimately, the Azure NVA is almost just a step above the route server. Route server can only do eBGP, and has some limitations around its size of route tables and size of route peers, right, and the amount of route peers it has. The NVA is just a slightly more advanced version of the same thing, but also has some of those additional kind of concepts where you could quite easily lift it up to a firewall.
Yeah. Maybe it's for those sort of cloud native-ish larger organizations versus route server might. Yeah, I'm just trying to think of where I would place them. A bit more of the still running some on-premises things, may not be as large to need full capability and mesh networking.
Yeah, it's definitely one of those challenges. And I think the NVA is really strong in more that multi-cloud context, where you've got probably that scenario where you really, or really strong kind of use case for NVA that I've seen recently was Azure Virtual WAN. So if you've got multiple vWANs across globe, then the NVA in the middle of that's really powerful.
Yeah, because it's vWAN, not hubs, which I always get confused about. It's like,
it's not
wait,
hubs,
but we've got multiple hubs. It's like, no, virtual WAN is different to the hubs within that. So it's always confuses me when people start talking, because people, like, the terminology gets interchanged with that. It's like, are you talking about multiple virtual WANs, or are you talking about hubs within the same virtual WAN?
And it's such a unique thing, right? Obviously, we get that scenario, and networking guys are horrible at it. We love our TLAs, our 3-letter acronyms, but we also love just swapping them randomly. So yeah, we're very bad at that in networking world.
I don't see any more questions on the chat.
No.
So for people that I know want to get into networking for the first time and want to learn, because obviously there's a bit of a difference between on-premises networking and the network obfuscation through Azure in terms of like the Hyper-V layer as well. So what would you recommend? Microsoft LearnDocs? Is there any other resources to kind of get?
you know what? I say this with a pinch of salt. On-prem networking skills are still so relevant to the cloud, and all you need to learn is just a little bit of translation language. How do I, if I'm doing this in my corporate data center, how do I achieve the same thing in a cloud? And it's literally all it is it's instead of it being a VLAN, it's a VNet. And it's simple, it's really basic language shifts. So, and Microsoft Learn have a really good series, and there's a certification around Azure networking, the AZ700, that has a learning track that as I'm now coming on board, I'm a newbie to the MVP program. I'm hoping that I can get involved a little bit more inside the learning track for that particular certification, because there's some really cool things that are in that. So look at the AZ700 learning path. That's a really good fundamentals. Also, there are plenty of people out there that are doing like kind of like the network fundamentals for the cloud. There's a couple of good YouTube series around that as well that have got the more of that language piece of doing here is actually this here, and they actually also go a little bit beyond Azure. They kind of go if it's this in your VLAN here and it's a VNet here and it's a VPC over in AWS and in GCP it's called this as well. So people are doing that a little bit further exploration as well.
The tips for kind of that I always think in the back of my mind is treat the NIC as a router, and network security groups as an ACL that flood down to the router, that flood down to the NIC. So I think if that's how I tend to think of it, and I think it almost simplifies what's going on, because you're going, well, actually, if you just take out everything else and you consider all the resources connecting to a NIC, and then that's your router, where's that traffic going from that place to that place? And it makes it a bit, I don't know.
And the network topology right now in Azure has had some recent changes in kind of middle of last year, had a really good uplift. We can now do packet capturing natively inside the cloud now, which is a bit of a mystery, right, and a bit of a dark art in before that, but we've now got really clear packet tracing. We've got very clear IP flow verifications now built into the portal. So if you've got an Azure Virtual Machine, you can go to the network card, and there's a whole another section under that for Network Watcher that has a whole lot of additional features now that are very valuable when it's troubleshooting that, well, why can't I get to here? Why can't I get to that? And it will go through and validate your network security group that's associated to either the NIC or the subnet, and it will also go through ASGs if they're there. So it'll iterate through and help you troubleshoot that process. Network engineers are also incredibly tactile. They love to get their hands onto it. Virtual networks don't cost you anything to build and to put together. So go ahead and create yourself an Azure free account and just throw a whole lot of VLANs into it, throw a whole lot of virtual networks into it, and get things connected, and just get a couple of virtual machines on either side and just validate your thinking, validate how you process, how you would think they're going to connect.
Yeah, that's a good, so there beats nothing else than getting hands-on, and to refer to a previous session as well that Marcel done on Azure Developer CLI, you could essentially wrap a lot of those Azure networking resources into an AZD deployment as well, and then spin them up, do your testing, spin them down when you don't need them. So
I think one of the other things I always like to try and challenge as well with network engineers in particular, they love their CLI. So go ahead and learn Bicep. Learn a little bit about how Bicep works and how Bicep works in networking in particular, because I think it's actually really quite cool. You can kind of get a flavor of how it kind of builds out and comes together through something like Bicep as well, without having to learn the whole Azure resource management structure, right, and all the JSON behind that and underneath it. So if there was, I think CLI is a really easy way to start, right, when we're going from, kind of network 101 over here and what we would do in our Cisco CLI to Azure. I think definitely the Azure CLI is the right place to start there. And I think if you're elevating beyond that, the packages like Marcel showed us earlier today are a really good elevation of that. And then beyond that as well is then going towards that full automation of Bicep.
Yeah, it's a good call out, and then work your way up to service endpoints are outbound and things like that. So you can get it. You layer on that knowledge from bit to bit. So
yeah, definitely.
Well, thank you for coming and presenting to us today. I think we're pretty much really on time now. So, yeah, thank you for being the last session of the day and very
No,
informative.
thank you, everyone.
Well, and we'll be back in just a couple of minutes just to finish it off. But thank you very much, Chris. Thank you.
Thanks, everybody. Thanks for having me.